Yeah, so I'm Jason Arbon, and I appreciate your time. There's a lot of humanity going to be spent here over the next hour. Actually, 3 hours. Did you know it was 3 hours? But yeah, I want to talk about testing and AI bias, right? Just testing these things. Because there's a lot more AI in the world, and we don't know really how to test it. Nobody really knows how to test it very well. And there's this thing about bias where people think that the world's going to end, depending on who you listen to, when machines start doing very bad things without our permission and things that we wouldn't think are appropriate or ethical. So this is really, I think, if you think about it, this is kind of a next wave of testing, I think, that's coming down the road. But it's also super important because it's not just does the dialog box work, can you log into the app correctly? This is actually going to impact, back to culture of quality, our culture and our humanity and our human experience. And we'll see some of that. So this is just a quick headline, just to do scaremongering. I'm not going to talk about zombies, but AI is sending people to jail. This is just like, I just do AI, news, and this is what's coming up, right? So I'm not making this stuff up. That was dated, when was this dated? Yeah, earlier this year. What else is AI doing, right? It's basically launching missiles, right, into other countries and identifying people in other lands and targeting them. It's not good. This is like a DARPA hard problem. So if you think it's a hard thing to do to test AI, it's really hard. It's literally DARPA hard. And then to pull a little Diani, anybody heard of this new Center for Research? No? It's new. It's in Berkeley. I'm not making this stuff up. Berkeley's, it's near Stanford. It's not that great of a school, but they have, they got to do something different to get some attention, like Diani. But basically the idea is this, is we need to make sure that our AI systems that we build are human compatible. And human compatible means compatible with human life. It's the most politically correct way to say, make sure the machines don't kill us. Literally, right? So this is kind of scary stuff. So who am I to mouth off about this stuff? I got lucky and my resume applies to lots of little things because I keep quitting everywhere. But if you look at this, I used to work at Bing on a search engine. Probably some of you have used it. Anybody? Oh, I guess we're in the Northwest. But it's just, but I used to work on this thing, right? And I'll tell you some stories about it. We'll talk about it a little bit. But I used to work on, at the time, I was a tester for what I think was the largest neural network at the time, literally on the planet. And we're competing with Google. And Google didn't use AI and neural networks at that time. And then, like a trader, I moved over to Google and I worked on search over there, right? I worked on Chrome and I had a secret engineering team working on, of all things, adding bias. I'm going to be careful. I can't talk about my work at Google, I think, totally. And then now I work at test.ai. And the awesome thing is this, because we're always like, who tests the automation, right? We're building systems at test.ai that are AI-based, and we have to test those systems, right? So it literally is that turtles all the way down. So I'm also experiencing and been playing with how to test systems that are AI-based to test other AI-based systems. So really what I want to do here is just share what I've learned. I think it's really early days. We'll probably laugh in 5 years and look at this thing on YouTube, unless Phil politely takes it down. But it's very early days, but this is a glimmer and just sharing my experiences testing these systems so that you're ready when it hits. When your team wakes up and says, we've added an AI feature, right? And start to try to test the untestable. Does anybody here have a project that uses AI in the product as a feature today? A few? Okay. I'll bet within 2 or 3 years, it'll be probably a third of us. And in 5 years, it'll probably be all of us. So we asked Google, because it's unbiased. There was some irony there, right? What is the definition of bias? And it says, not me. And then the second result is it's just prejudice in favor of one group over another one, right? And usually in a way that's inappropriate, right? Or wrong or unethical. So I'll start with this. I have a marketing team now, because I talk too much. So if you want to go to test.ai or whatever, or our LinkedIn, you can download a pamphlet. I really just put this out to share all this information. It's like an ebook that's 45 pages long. So if you want to reference it later, it's out there. An introduction. So I'll say the reason I wrote this too, or put this stuff together, it was, we even changed it. I was talking with Phil like a couple months ago. I was listening to some podcasts and reading some New York Times articles and listening to some very prominent people talk about their fear about bias in AI. And I'm sitting there as a tester going like, well, and what do we do? But if you listen to it and you read around, they're just concerned, but there's nothing actionable, right? There's really very few people saying, how do you fix it? How do you test for it? How do you make sure it doesn't enter the system? So that's what I just want to share my early learnings on this thing. So the spoiler alert here is, I finally realized, this is what I do, I'm such a nerd. I spend like a Saturday and a Sunday and I'm stressed about this and then I cathartically write something in the afternoon. But the key thing I realized is that everyone's trying to remove bias from AI. The reality is that AI is actually bias. It's inherent bias. It's all bias. The question is just whether it's good or bad bias. And we'll explore that further. So we're going to talk a little bit about, without getting too much into the math and all that kind of stuff, we'll talk about training data. Everybody's heard enough this last couple days to realize AI, you take a bunch of data, you feed it to the machine, and then it tries to replicate that, right? So we'll talk about, from a tester's role, how do you look at these systems, the training systems and these AI systems? So we'll talk about training data and how to test it. We'll talk about training processes. So how is that data, how does it trained? How is the machine trained and iterated? We'll talk about productization. So when you think you're done, most AI teams think when they're done, when the training's done, they ship it, right? That's when chaos begins, actually. So really you think of this as really a shift left and an extreme shift right at the same time. And then AI does most of the stuff in the middle. We'll also talk about testing AI-based testing systems because that's the most nerdiest thing we could talk about here. And we'll talk about the future. I love talking about the future because it's all BS and no one ever holds me accountable to it. I'll tell you, there's one Easter egg in there, and if everyone goes, oh yeah, that's, then we're all fools. And some Q&A, which you probably won't get to. Does anybody have an idea what this application is? This web app? It's a search engine, right? So it's like a rough, crude approximation of Bing or Google. So what we're going to do is we're going to talk about bias in the context and how to test these systems in the context of search engines. One, because I've played with a couple of them, and also two, because everyone here has used them, right? If I used a medical example or a legal example, everyone would go to sleep. So how do you train, even if you want to go build one, you want to go build a search engine this weekend, it's ironically pretty easy these days. So all you need to do is get 30,000 queries. So these are searches. So if you think about a web page, it's a pretty simple input-output function, right? You've got input, which is what the user types the query in, what they're searching for, and you have an output, which is just 10 blue links to web pages. It's the simplest app in the world. Ironically, it makes the most money in the world. I don't understand this. But the beautiful thing is that, guess how you start building an AI-based search engine? Most people think it's a bunch of engineers. It literally used to be 1,000 engineers, all their postdoc, PhD folks, thinking about algorithms and linear algebra and trying to calculate these things, right? The reality is in today's world, you just get a bunch of queries, search queries, and you get a bunch of web pages, and you ask humans to rate them on a scale of 1 to 10. So we literally, what's powering these search engines today, and most people don't realize it, is that we go out to people in the real world and we say, here's a search query. Someone typed in Red Robin, and there's a web page with a picture of the Red Robin restaurant, and they go, that's a good result. If the result they ask for is a picture of, I don't know, Tender Greens restaurant, they'll go, bad result. And then we use this data to train the ranker on the search engine to put those blue links in the correct order on your web page. So we talked about why it's 30,000 queries. There's a lot of little nerd points in here. But really is all you do. You take these search queries and these possible web pages, you give them to a bunch of humans. There's humans out in the world that do this. Usually, by the way, they're actually in their pajamas usually. And I'm not kidding. They're on their couch. We've asked them this. They're on their, because we're worried about even the bias that might be based on where they're doing the work. Because we're getting really nerdy. But they're on the couch in their pajamas, and they work whenever the hell they feel like it, right? It's kind of an interesting job, but monotonous. So we also give these people guidelines, right? In the early days, we didn't give anybody guidelines at all. Today, this is the example that Google had to publish it because people were getting work. I think the EU was getting upset. These are the guidelines. It's like a 90-page document that all these humans have to read to tell them how to score that page and that query pair and convert it to a number between 1 and 10 for training data. But start to think here, right? What was the problem here in terms of bias in a search engine? Before we start, we've brought humans in, right? Humans suck. But we brought, sorry. That's why I focus on automation and bots all the time. But, yeah. Hey, real quick, there's two options. The humans win or the bots win. Like the humans win, I'm pretty fine, chill, right? We're all here. If the bots win, this is I figured out over beer with a friend a couple years ago. I said, I think the major blocker between here and the bots taking over is them being able to test themselves. It's easy to generate a lot of lousy code and AI code. It's hard to test them. So if I teach them how to test themselves, they'll just go like, thank you, and every 300 milliseconds pay homage to me with a no-op cycle in the CPU. So I win either way. But the problem here is we've introduced more human beings, right? We've introduced people, some small team at Google wrote this document, right? And they're all probably wishing to get promoted off of that team to a better job. And guess what? They probably all went to the real school, Stanford, and they have all those inherent biases that you're starting to think about, right? So now we've got bias from people writing the guidelines, having humans that also have a different bias, building the training sets for our search engines. By the way, can someone give me a signal when we only have like an hour and 40 minutes left? There's a lot of slides. We'll get through them. So this is as technical as we'll get. So now what do we do? And we'll get into more of the bias. So how do we build a search engine, right, from all these data? We just have a bunch of queries and a bunch of websites with scores 1 to 10 on how good they are. How do we teach a machine today to replicate that human judgment? We created a brain. Literally, we start with a randomized brain. It doesn't matter. It's just neural networks that are kind of randomly configured like Tariq's. And then but it was an amazing, some random configurations are pretty cool. Just happened, statistically. So what we do is that we want to show all this information to the machine to learn and train on, right? So what do? We simply give it a web search result for a given query up at the top, and we say this was a 0.7. The human said that was a 0.7 or 7 out of 10. Is that some good math? See, I did that on the fly. So then what the machine does is, machines can't understand what a web page is, right? What they can do is we calculate things called features. What the features are, the number of times, for example, the query string you've typed in. If you typed in Red Robin, the number of times, I obviously have kids. Oh, the water sliding, that was awesome. That was cool. It was like, we do a simple calculation and say how many times Red Robin appears in that web page. Because we have an intuition that that's probably more relevant the more times it says Red Robin on the web page, right? So we basically compute this number. It's another number between 0 and 1. So you might say that the percent of all the words on the page have Red or Robin in them. You might do the same thing focusing only on the title of the page, right? The title of the page may say worst restaurants in the world, and then the content says Red Robin, Red Robin, Red Robin, right? But it may not be, it may be a spammy site, right? And then again, you may also have some other measures, other neural networks input that say how likely is this to be a spammy web page based on the domain, based on the content, the color of the screen, who it's registered to. And so all these features now get converted into feature work. They're ones and zeros into the AI. So the AI just sees these ones and zeros kind of passing through. And then it makes a random guess. And it might say 0.9 randomly, because we're a random brain again, right? And then we go, no, dumb robot, bad robot. And then it goes in and it cuts. You can see little cuts in some people's heads. But it goes in, you cut, and because you go, this configuration's bad. It's not a good configuration, right? It's not the ultimate configuration of a neural network. And so you change it, and then you keep feeding it these different examples, right? Another one, here's for the given query, this website is 3 out of 10, right? We compute these same things again, and this time it guesses a 0.3, right? Now guess what we do? We go, good robot, you randomly guess the right thing, and then it go in and they reinforce that, right? They say whatever connections we have right now are good, so try to remember this for the future. And this just goes ad nauseum, right? We're going across 30,000 queries, and we might do 10,000 iterations across those 30,000 queries to train a neural network until it converges on a configuration that seems to emulate the human input. So that's the roughest slide in the whole thing. So now what do? We built this little tiny brain represented here in this little network of nodes. So we've got this neural network that's been trained and kind of replicates those humans, right, that we're judging the website scores for a given query. So now in production, when somebody types in a search query for, say, Red Robin, we send that into the neural network. We also pass in some candidate web pages, right? And what the neural network does, because we've trained it to do this, is it outputs the number, because now it knows how to produce those numbers. So it'll say, oh, that web search result is worth 0.5. Another one comes in, oh, that's a 0.3. And this one, 0.7. Now realize this query may not have been executed ever before in the history of humankind, right? But it knows that based on how many times that it's learned heuristics on how many times the query string appears in the title or the body, this is usually the score to produce it. So it can replicate that judgment on queries the machine has never seen before. And so now if it gets these little web pages, little web snippets, and it puts them in the order, it does a sort, which is very complicated, a whole nother slide deck. You now have web search results. Voila! It's kind of easy, right? Why does nobody compete with these people? So anyway, so now we have search results, right? We've seen already humans have been involved in a couple stages of this process, though. So let's talk about specific training data, right? So one thing is you want to figure out where you get your data from. So where do you get all these search queries and these websites, right? So a lot of times, guess what people do? You just grab them from production, right? So what you'll do is, guess what most humans will do? They'll go, I'm going to go to CNN.com, I'm going to go to Wikipedia, and I'm going to have a web crawler and just follow all the links and find all the web pages, right? That seems like a pretty reasonable thing to do. The problem is you only find about a third of the web, because most of it's not linked from the top websites, right? So inherently now there's another sample bias, because we're only indexing sites that happen to be very popular or linked by popular pages. Even worse is these things are also biased by language. So guess what? Most of the content on the internet is English, right? For a lot of reasons, cultural regions, the origin of the internet, commerce. So guess it takes money to build a web page, to write a web page, right, and have a computer to read that web page. So the internet's already biased toward money. Also education level. An extreme example is if you're illiterate, the search engine probably won't work very well for you, right? It's kind of like weird educample, but guess what? That's probably an exact segment of the world we really probably should help, right? And then there's cultural demographics, which are the easy, almost the easy, too easy, obvious, cringy, horrible examples, right? But what I want to say is this. Most engineers will say, okay, well, let's get rid of bias. And again, we'll sample all the web pages, all of them, just all of them, right? The problem is, guess what happens? Just like society, right? There's different demographics in this room. All different demographics, right? Race, sex, I'm getting in trouble for listing all these things. You know, social economic background, where you grew up, right? Whether your parents were mean or nice to you as a child. There's a lot of demographic difference in here. And so guess what? If half the people in this room, we're talking AI and bias here, if say half the people in this room were Caucasian, guess what? We just built a Caucasian search engine with a little hint of other elements in there, right? So even if we think it was a fair average sampling of the community of web pages and queries, we've just created a biased, semi-racist search engine, if you think about it. I did not expect laughter at that transition. I'm trying to be real careful not to be, all right, easy crowd. So a myth here is also, so we're going to go out, okay, regardless, we'll try to get as much data as we can. We'll deal with some more of this bias layer, okay? So what do? How do we get all these search queries and websites? Well, we go to production. We go to the production web to crawl those things. And if you build a tiny little web search engine, right, from Microsoft, and you pre-install it monopolistically across every device, and people load it up and they think it's Google, which is actually the case. I think 26% of our users thought it was Google in the early days. They type in search queries, right? So, but now we've got a flood of search queries, right? We could make them up, but it's better to get them from users, right? That makes more sense, rather than from a bunch of engineers. Don't read this. But guess what happened? Most of our search queries were from, and we're talking demographics and bias, were single mothers with multiple children in Ohio, was the centroid of our user base. These are people that either don't know or don't care about, there's another search engine called Google, right? There are people that are not technically competent to switch their search engine default, right? And so guess what? All of our search queries come in about Britney Spears. Literally, this is our problem. It's about Britney Spears and like all this other crap. So now what do? Now we realize we're biased toward building a search engine for middle America, right? And then, Florida. So, I'm sorry, I don't know why I did that. I shouldn't do that. I practiced that 8 times yesterday. So this is the problem. Let's see else here. More techie. So we'll leave it at that. So we'll talk about that later. How do we fix that, right? And it gets worse as we go down. So one is, like we talked about a second ago, we think we should do random samples. So say we have all these search queries, and we're just stuck with all these Britney Spears queries and stuff, but that's all we've got, because we can't get Google search query data. That's private and secret, right? So what do? Well, we take what we have, and we start a search engine from there. And so there's 2 things. You've probably heard a couple times this week. There's the training data, and there's test data, right? So what you do is you take all of your training samples, you take out some of them, and then you train your robot, and then what do? Classically, like we do in test, you test against another separate oracle that wasn't trained on to see how well that knowledge transfers to things that's not seen before, to make sure it's not overfit. So we need to separate these things out into training sets and test sets. And I'll tell you, most of the ML AI folks I talk to, they do this random sample and split it up, do it randomly, and they think they're awesome. They've not introduced any bias, right? But there's a temporal bias. There's lots of bias. So when did we sample those queries, right? Was it today when we start having little baby turkeys that are starting to get fed? But it's real. Like, and then 30 days from now, guess what? There'll be lots of pictures of turkey dinners and plates and queries about cranberry sauce, right? So how do we deal with just temporal drift? Forget drift and bias because of these demographic things we don't like. We're going to have functional problems and quality problems in our search engine if we make a version today and tomorrow is going to be different, right? Oh, Yanni looks skeptical. So what you do is, what we did naively at first, we take 30,000 queries from a random time during the last day, right? And we go, awesome, that's a perfectly random sample, and we train on it. So we're going to go through a couple things. You're probably thinking about them because you're testers. These aren't really exciting, but they're fun. They're very nerdy fun. And guess what? We had to learn these on the fly and go, oops, oops, oops. And you'll realize when you test AI systems, every time you think you fix something, you uncover something else. It's like a Brandon Sanderson book, if anybody's reading these. There's always another secret, okay? So time of day. When we started that sample of queries, was it during the workday or was it after hours? People are searching for different stuff, right? I don't. I search for work stuff all day. I was just thinking on the fly. I'm like, well, my query stream doesn't change. I was doing Python queries at 1:30 on Monday morning. Weekend or weekday, right? That'll be different. Is it movies or is it traffic? Was it a holiday? Again, I'm getting scared. Is it weather? Yeah, weather, exactly. The weather can impact these things. It could be news events. It could even be crazy, like different years. Different years, like could be the year of the dragon, right? Or it could be a year where there's political unrest in the country or an election year. And the search queries, the web content and all that stuff are changing all the time. The problem is when we choose which set of data to train on, we're biasing that search engine for a specific temporal interval, right? And there's temporal structure to that data that we're training on. So we got really smart. This is only, by the way, to be clear, as long as I was there, probably this is part of the problem, come to think of it. This is about as smart as we were, is that we would take a bunch of samples from last week, fewer samples from last month, fewer samples from last year, and even fewer samples from the year before. right? So the idea was that if we had a temporal bias that went backwards in time, it might capture a lot of the texture that we expect to happen forward in time. And I did that backwards, ironically, in my gestures. But does this kind of make sense? So you got to think about sampling, not random. Random is actually the most root cause of all bias. So another thing is, how do we know we have enough samples? It's almost like a presidential poll. There's nothing sacred these days. Say there's a presidential poll, right? And there's a 1% minority in the world, but you only ask 50 people. What statistically are the chances that you're going to even have that part and that opinion represented in your sample, right? It's less than 1. That 1%, which is a pretty big slice of the country, not even represented in your poll, then you have a chance statistically. When you magnify it by the diversity, does anybody notice there's a lot of different shit on the web? I said it. There's, at some point that's a trademark, I don't know, it's accidental. But there's a lot of different stuff on the web. Oh, now, yeah, there's lots of different types of stuff. Which, by the way, was 33 or something % of our queries at Bing. That was awesome. So like you really need to understand the texture of the data, right? If you're only polling a single town, it's a single Mormon family has dominated that town, and they're a polygamist family, so they all have the same political bias, then you don't need that many samples, right? If you're polling the middle of Portland, you probably need to poll everybody, I think. But you need to understand the richness and texture of your data to know how to sample it, how many samples you need. The crude way we figured it out, and it's a common way to do it, is it's embarrassingly simple, is we just keep changing the sample size until our scores don't change, right? But that doesn't really mean, because that's based on the bias of all the other stuff that we've had upstream in query sampling and training and measurement data. It's not good, but you got to think about are you sampling enough to represent the texture of the thing you're training? There's another fun stuff, is bias and labeling. So here's this is the biggest tragedy on the planet, I think, that no one ever realizes, and nobody seems to care except for me, and that is that, guess who these people are doing search ratings? Is it anyone here? No one's done it? I don't think so. You have? I know people that have. You know people that have? It sounds like she did it. Because she knows what's coming. These people do not make more than $20 an hour. In fact, a lot of times they make $7 to $10 an hour, depending on the minimum wage, because it's minimum wage type work. Those people are training our search engines. So when you're going in and looking for Red Robin, maybe that's okay. If you're doing a query on a Python library, right, or something to do with testing or AI, our engines are trained on the input from people making less than $20 an hour. They're not software engineers. They're not lawyers. And by the way, they're not medical people. If you think about this, when you do a query on Google, and I don't know the data on this one actually, but I have a pretty strong hunch because I've been around these things. If you query for like a medical condition, any medical condition, right? Tariqitis or something, I gotta think of something. When you pick medical terms, there's never a good one. But if you pick a medical term and you search for it, guess what comes up in the top search results? All the usual subjects, right? Suspects. So it's going to be like the Department of the Health, it's going to be like the Mayo Clinic and whatever. It's pretty bland stuff. And the reason is because those guidelines the people are getting, they don't know if it's good content or not. They just go, they really do things like this. Is the word that I searched for, tariqitis, does it appear many times in this document? Right? That's the measure for quality in this stuff. So there's really almost no testing and really no notion of quality, again, to do the promo, that impacts our culture, right? It impacts our information, our ability to find information and share information. This is the scariest thing, I think, today. And I proposed, but it was ridiculous when I was doing this stuff, we should actually pay lawyers and doctors and stuff and sort the queries by the type of profession that they are, and also basic Madison Avenue demographics, and get that ratings data for those segments of the population. You know the problem? I don't share this very often. The reason we couldn't do it is that Microsoft didn't have enough money. Like, that's a funny thing. That's supposed to be funny. Microsoft didn't have enough money because we spent over $20 million back in the day on these raters, right? If I want to increase that 20 times, right, to capture more demographic data, let alone the increased cost of these other demographics and the hassle of finding them and getting them to actually do this boring behavior, guess what? It's $400 million. And we wouldn't even know until we got all that data, trained the AI on it, measured it, and then asked people if it seemed like a better search engine. So I was denied a $400 million data experiment. So then guess what every good-natured person does? They try to clean the training data. Has anybody done this? Probably not here, but. So you look in the training data, you look, oh, there's some garbage data over there. I'm going to remove it because I don't want to confuse the robots. The robots only have so many things to learn from. I don't want to give them bad data. Don't ever touch the training data. And if you want to touch it and you think you should, still don't. Call a doctor or me or something like that. So at Microsoft, guess what even people at Microsoft were doing? They were looking through the search queries on Bing, and they removed GUIDs. Any old school folks know what GUIDs are? Yeah, they're like unique identifiers for a DCOM interface or something, and using your nicks. So these look like random jumbles of numbers in parentheses or brackets, right? So they go like, oh, that looks like a junk query by some crazy person, right, that typed in the web search engine. Why would we train on that? So they would remove those. But that meant we didn't do well on GUIDs. So if you're a Microsoft engineer, try to type in a GUID on Bing, guess what you did? You went to Google. you didn't go to Bing. Mumble wrap, my kids introduced me to this a couple weeks ago for fun. I would probably even still remove mumble wrap. There's deliberate misspellings. This is the funniest thing. We were always comparing ourselves with Google, and we go like, well, why is Google so good at misspellings? Well, it's because, guess what? We removed misspellings from our training data. Because they're misspelled. Why would we teach the computer how to misspell things, right? Because humans misspell. And then lastly, the bias of the person cleaning. So it's not just that these are random things that we're biasing the data set. We need to test to make sure that people are not doing this kind of stuff. But the person, there's usually like one or two people that are cleaning the data. They have immense impact on the resulting AI system that's produced, right? Because they're doing the ultimate cleaning and cleansing. They're basically the god of this AI and saying what it can and cannot do and what the limits are. And if they have a bias that's different from any one of you, you're negatively impacted. You scared yet? Who trusts AI systems now? No. So again, this is going back to the training mechanism, the training documentation, right? So there's even more thing. There's another thing we always think about in testing. We think there's truth. For a given input, there's a correct output, right? That's usually how we make money, in case you didn't know. But the reality is for search queries, somebody could type in Bush, right, and get 4 people think George Bush is awesome, right? One person who doesn't pay attention to politics, probably plays a lot of video games, thinks Bush the band, the rock band, is the best result. There's a Bush fan. Machine head, right? Sorry, I went into computer science. But guess what happens? This sucks, because now we're teaching the computer, there's 2 opinions. So now it will never get it right. Guess what the AI does, though? It tries to average. Remember, average is a bad thing. Averaging and randomization is a bad thing, usually. So guess what the machine does here? It goes, well, I kind of think George Bush is good. The Bush, the band, is okay, right? But we survive as a humanity and a society because we still have 10 links, right? So it'll be on there. What you want is going to be on there somewhere in the first 10, but they're not going to be in the right order for you, probably, if you like Bush the band. So this confusion is called confusion. If there's training data that says that for a given input, there's 2 possible outputs, it's not good. The machine re-encode that confusion into the system, right? But there's a funny thing. There's no right answer. So does the Earth revolve around the sun? I guess is what I'd say. True or false? True. Yes. That was actually me going like, yeah, I think so. But if I asked you that same question like 600 years ago, what would be the answer? It'd be what? Maybe. It might be maybe, yeah, depending on how close you are to the local church authorities, right? And so what's interesting, that's an interesting analogy, actually. So just like the Inquisition, you're like, what is that transition? Guess what they did with this person that said the band was the best result? They fired him. because the vendors want to make sure they don't lose their contract with Microsoft. So they want to give really clean data to Microsoft, right? They don't want to put confusion. Confusion sounds like a bad thing. So they would proactively get rid of the people that added confusion to our training set. So now we never did good on Bush the Band, and this person will always play video games the rest of his life, probably. Which is, I guess, the career path I'm telling my kids to take. So anyway, so there's a lot of biases that get into these systems. So we have to test for them. Testing sometimes means making sure people are not doing bad things. Testing means looking at the structure of the data, analyzing it, looking for these kind of problems in sampling. There's non-traditional testing activities, but if you as testers don't do it, guess what? The machine learning engineers don't usually do it. They're just happy they get a score and they ship the thing and they move on with their promotion. So let's talk about training process, right? So again, we're taking another place that we need to test in these AI systems that's super important is that we have a web page, like we saw earlier. We convert that to text, and then we count the number of times the query appears in it, right? That's a simple mathematical function. It's literally a simple Python function, right? But guess what? Somebody wrote that Python function. And sometimes those things are off by 1. You can imagine off by 1, counting the number of times the search query appears in the title might impact the search engine significantly, right? So what often I've seen in machine learning and AI teams is some engineer will go build these little feature, there's a little bit of feature, call it features, there's a little feature work, and nobody tests the stuff. And so you find out like 4 months later when you're debugging things and looking through stuff, oh, that always miscalculated that number incorrectly. Because the worst thing about AI is it will try to heal. It'll actually try to overcome the stupidity in the humans. So it will try to cover up these kind of problems as it learns. Because it will learn incorrectly, but it's trying to reproduce the same output. So you basically get a search engine that's never optimal. So test these things. If there's a feature, if there's functional code somewhere, you need to test it like it's an API. Also test the training system. So when we talk about the training system, there is actually infrastructure that takes a bunch of the data, throws it through the machine learning algorithm, and then outputs a model file, right? Those things in any decent-sized organization are a significant amount of compute. You have a lot of containers. You'll have like a lot of cloud infrastructure. You need to make sure that all those things are working and test them as if they were a software system. They're infrastructure, but it needs to be tested because things like scale. Guess what happens at scale? We had a problem with scale. Because when we tried to hit 100 servers at once, right, and we had a timeout of like 150 milliseconds to get a response back from them to get the web pages to do the training, the machines that were slow, we just never got the data back from them to train on. So you end up with functional and data problems because of functionality. So, and even when you score these systems, there's a lot of reporting dashboards and so on and so forth. You need to test those as if they're your product. So there's another interesting story. Lots of little fun stories, I think. I think they're fun. So I woke up and I'm the test lead for this relevance measurement stuff. And everyone for several quarters was giving this one engineer a lot of money. Like extra, what do they call it? I forget now. I got one. A gold star award, I think is what it was. There are secret awards that Microsoft gives people that they don't want to leave to Google. And there was this one engineer that kept silently getting them. I found out about it. And he was like, everyone's like, wow, he's just super intuitive and the best engineer we have on this AI stuff. And that's, out of like 60 folks, he represented the majority or almost the majority of all versions of the search engine that were better than the last, right? So you don't let that person leave, right? Well, guess what happened? So I'm a tester that had the testing mindset, right? I want to go back to even like Bolton, although I don't know if you'll appreciate it. But you just question everything, right, as a tester, especially in AI. So I questioned him. I go like, what is up with this guy? Why is he so smart? I talked to him. He's like, I don't know. Like I have an intuition and I add how many times does the query appear in the bottom of the page. And it gets better. It builds a better search engine because we don't know how it works inside. I also noticed I looked into compute. This person ran a lot of our compute power. So he was using the bulk of our computing infrastructure were his jobs, right? For a long time, people just submit jobs, and we made the machines bigger and more machines to account for the engineering training time and all that stuff. But he was accountable for 50% or more of of our infrastructure. So I'm going like, but then you go still. Well, he's a really smart person. He's putting all the infrastructure to work and stressing the system, and he's building better versions of our search engine. Like life is good, right? We went this way for like 2-3 quarters. The problem is this. When we were doing our training data, remember I told you we sample over time. So the training set and the test set were slightly changing every day, right? So what this guy did was he would take another engineer's model or his previous one, and he would just resubmit it to the system in a cron job, little batch file. So everyone else would take their thing, they put it through the system, and they get a score. And then they would go, well, I'll try something different. What he did is he didn't realize he was actually the worst engineer we had, because he didn't realize that AI has a confidence interval. It says, hey, you're a 36 out of 100 with plus or minus 1 point, just like a poll, right? So guess what this guy was doing? Retaking the poll over and over again, right? Because the data slightly changed. In this analogy, people's opinions slightly changed by the news. And so then he would only record the high watermark scores. And we had an automated system to make things efficient. If you had a neural net with a higher score, it would go to production. Sounds like a CI/CD pipeline, right? So we were automating this horrible degree of engineering, burning most of our compute, and we're giving almost all the money to this person and not letting him go to Google when we should have sent him to Google. So this is the other one. So this is what testing in AI sucks, because you're the bad news bear. You're always the bad news bear, far more than functional testing. You go, it crashes when I do this. They go, well, don't do that, right? But when you have teams, I wake up in the morning, because it's a global world, and the Google in Japan, it was a separate engine for Japan. They said, hey, we just kicked Google's butt in Japan, right? And guess what? Emails, Microsoft, congratulatory emails, it's going all the way up the report chain. Yay, good, how did they do it? They're awesome. Hey, can you guys fly out immediately and tell us how to do it in America? And I looked at it, and guess what? They had almost a perfect score. So Microsoft versus Google, I don't know, his data's past statute of limitations. But say Microsoft was at like 35 and Google was at 37 out of 100 in terms of score of how good the search engine is. They got like a 95. Suspicious, right? So I'm going to have a horrible day. So I got to ask them for their data, ask them for their training data, do the analysis, test the data, right? There's a few things. One of the most obvious, craziest things is they accidentally tested their net with the training set. So it's like they had the answers to the quiz before they took the quiz. They didn't, I don't know why. And you know what their first answer was? I actually said this. I said, why? And they go, well, they're all PhDs. Literally, that's what they said. The other thing was there were a lot of queries that were hard. They were really hard for their search engine, difficult to do, especially with language-specific, region-specific queries that were in the set. So they hard-coded them. So if the search query came in, well, you can't handle that, they had an if this, then that put in there. And you'll see this. Sometimes they'll do it for quick fixes. Sometimes they'll do it maliciously or whatever, or cover stuff up. Most of the time, it's just people are naive. The problem is that, I don't even talk about the problem. That's horrible. That's, I think, cheating to get into, on any test to get into school will get you in jail, apparently. So another problem we had, back to that sampling of user interaction. Everyone thinks that Google and Bing use the click traffic to bias search results. So if everybody starts clicking result number 2, 2 goes to the top, right? It's not really true. It's like one of 100, 200 signals. But the reality is that every engineer at Microsoft was using Google, right? So all of our training data was going to Google. And Microsoft should have kind of been okay with this, right? Because the thing is, you think, okay, well, let's fix it. So they're naive, they're functional people, they're not thinking about how to test AI systems. So what they do is they hard code the DNS resolution on the CorpNet to go redirect to Bing. So if you go to google.com at Microsoft, it took you to Bing, and then you did your search there. But the thing is, the IT guys weren't that clever. Because guess what? You can go, there's a thing called an IP address. So all the engineers that actually were worth their salt were actually going straight to Google still. The idea they had here was, okay, well, we need more Google-like queries and more engineering-type queries. So we're going to make our engineers use our search engine, so our search engine will be better at engineering-type queries. Guess what now, though? Now we're building a search engine that's got two personalities. It's got that lady in Ohio, right, in her pajamas, and it's got some really, 25-year-old nerd at Microsoft that doesn't know what a confidence interval is. And we're training on those two sets of queries. Those are neither monetizable queries, nor are they most of America, right? And so then a question arises, right? Well, oh, that's a fun one. What do you do? Like, you don't, the key point in this is there is no right answer. It is turtles all the way down. If you try to fix it, you actually cause other problems, right? So I don't know what the right answer is on that one. I don't know. Actually, I do know what it was. You know what the ultimate answer was for this? You can see it if you look on the net. It's kind of quiet. Oh, well, okay, I'll get to that. Exactly, that's part of it. That was part of it. That was the most nefarious part, though. Yes. Let's put them side by side. Do you know about that? You were there? Yes. Okay, cool. You know I'm not making this crap up. All right. All right. I mean, I'm not that creative, right? But the funny one is later they built, and I was part of this. I sinned. There was the browser extension for Bing would look and see what people were doing on Google. So we take those queries and train on those queries. So if you own the platform, you can do some other weird stuff like that. But most of us can't do that kind of thing. So exactly you know what's coming next. So then guess what everybody does? So at Microsoft, if Word crashed on you or something, you would email the VPs and directors would email that team and go like, oh, here's a bug. They were superheroes. They cared about the product and quality. And they'd send off a stack trace or something, right? When we give them a search engine, guess what they do? They go, I searched for Red Robin, and my local Red Robin was position number 3. Okay, well, they're not a search expert either, right? But again, if we took their feedback, like a bug fix, guess what? We're bringing bias in, right? So now the most vocal VPs at Microsoft are now training our search engine. So we'll now have a search engine for like 15 people, right? And so what we did was this. This is awesome. You can do this in your own AI stuff. This is all. I fully condone this. I don't want to tell the person who had the idea. It was brilliant. It was not me. You're like, oh, yeah. But what he did was he put them side by side. I don't know. Were you on the Bing team?
No, but
You saw this or? Okay, yeah. So for a while we said, okay, we're going to you do one query, and then we'll show you in iframes Google and Bing side by side. And then guess what you could do? You could say which one was better, right, to help the company. And you could even later highlight which was the correct result. And you even had a text box in the bottom where you could type in the correct result, as if there's a correct result in AI. So we got a lot of feedback. Now you're going to be mad at me. Do you know what we did with that data? I trashed it. Went in the shredder. We just wanted people to shut up. Because it was going to bias our search engine, right? But it's beautiful. Just create this honeypot. Oh, we just want your feedback. So testing AI is a very different animal than testing functional stuff. In functional, you want every reproduction of every bug you can, right? In AI, it's almost the complete opposite. It's noise. So productization. Actually, I'm going to be really crass. How much more time do we have?
About 8 minutes.
8 minutes? Okay. That's cool for the future of all testing. We can do it. So UX matters, kind of back to what you're saying. So you build a search engine and get the results in the right order, right? We think mathematically we've got the right order. Say you've got all that figured out. We did studies over there where we put Bing results in Google search font and HTML and CSS, and we did the reverse. We put Bing in the Google search font and results. And guess what? People definitely liked the Google results better, even though it was Bing, because they have a perceptual bias, because there was brand association with that being a better search engine, right? So that was a little scary. Now what do? We're always the second fiddle. But then you start looking at it and you go like, oh, maybe Google's doing some things that we should learn from UX-wise, right? Maybe their presentation layer is actually better, right? Maybe that darker green, Google's famous for testing different colors of blue. Maybe that's a better color. Maybe people don't want as thick of a header at the top, for example. There's even like UX testing, but you don't have the answer. You can infer these things. You can run tests and experiments and flights to find out. But the UX doesn't end of the day. The testing has to go to the extreme right of how are they not only interpreting our product, but even relative to our competitors, how are they interpreting our product and the relevance of that product. So we may get the stuff in the right order, better order than Google, but we still lose because of a CSS file. Another thing here too, so that's very qualitative, right? How do you quantitatively make sure that your UX and your users are getting the value of all this AI under the hood, right? Well, one thing interesting note, everybody knows here, is it's a lot better to get the result at the top right, correct, right? That's what people look at first, because we're human beings. We don't look at the list of 10 and go, they were sorted correctly. We just start because we're lazy. We start at the first, the second, and the one that, it's good enough, we'll click the thing, right? Like little tiny mice, right? Like wanting to get a little pellet of food, or actually more like a turkey. So I should have worn orange or brown or something. So what we knew is there's a way to quantify the UX relevance of your AI-based system, and that is if you know that it's far worse to switch positions 1 and 2 than it is to split positions 2 and 3, you can do a little bit of math and now calculate when we get it wrong, how wrong do we get it, right? You can imagine even in Twitter. I think somebody in here has tested Twitter before. But the idea is when you do a search for a tweet, or it gives you, your relevant tweets, the ones at the top matter more than the ones at the bottom. And if you treat them linearly, right, you're missing out on a huge aspect of relevance of the product from an AI perspective. There's another one. This is all that, now you guys will like this one, I think. So we had this big meetup, and we're like, we're losing to Google. It sucks. And we had these meetings that was sad. About this many people, and we'd be in a room, and everyone would be assigned different types of queries that we suck at. And we divide up into teams of 5 and go like, what are they doing? How do they do it? And one presentation from the smartest researcher we had, MSR guy, and he was all in the deep, all this magic, computation and stuff like that, is he figured out that when we were doing our relevance measurement scrapes, we had to scrape our search engine to see how good it is in production, right? Well, guess what? The person who wrote that code said if we do an HTTP request and we get back a 500 or no response, we retry because there's no data, right? Well, he looked at the data in the logs of our servers and he realized if we fixed the functional aspects and reliability of our web service, if you counted a no result from end user, if they got a blank page, right, or no response, that's probably a 0. But if we mathematically calculated those functional failures as a 0, our search engine's relevance dropped by like a third. But we weren't measuring it. So you've got to be very interesting and careful about making sure that the functional correctness of your relevance measurement systems is actually correct. But that was the biggest impact for a year on relevance in our competition with Google, was a whole new team spun up to make sure that those servers just don't go down. So testing AI-based systems, a quick peek. This is not a list of test cases, is it? We won't go into the details. But this doesn't look like a list of test cases. It doesn't look like a bunch of Java or Python. It doesn't look like Selenium or Appium or any of this kind of stuff, right? This is how we test our AI-based systems. So we build classifiers to figure out, is that a shopping cart or is that a login button, right? So each gray chart in here is a combination of, we multiply it together. We're trying to optimize for the equal confidence of these two. But we're basically measuring how accurate it is and how much, and how, what is it? Come on. Accuracy and precision. We call it confidence in here internally. But it's accuracy and precision. So there's a trade-off, because if you want to be really, really precise, right, you lose on the other one. It's a space-time trade-off. So we plot these things. So each line is a different type of button in an application we're trying to identify with machine learning and AI classifiers. There's a wide variety of these. You can look at it as a wide variety. Well, why is there a wide variety? So this is what testing looks like when you test AI-based systems to test systems. If you look over here, there's a lot of bar charts. You're going like, whoa, Arbon, you said no math. But the funny thing is that all this really tells us is the stuff that the AI was good at is the stuff you would have realized it probably would be good at. It's good at identifying the Google logo. It's good at identifying barcodes. And it's good at identifying like 5-star ratings. And the reason is that they're very unique. So of all the things that are in applications, they look very distinct from everything else, right? Guess what it really sucks at? It really sucks at, the worst thing it sucks at is it cannot, for the life of it, tell the difference between a right arrow and a share button, right? So we're like, well, that sucks. How do we fix that? So we look at our arrows and we go, that's a lot of arrows. Looks okay. We had a human, not to be mentioned, Ryan. Ryan. He went through these and double-checked them. It looked all right. It looked like arrows to him. Guess what those are? I don't know. They could be shares, they could be arrows. It depends on who you ask sometimes. You have to go back to the original app to find out what that was. And again, there's still confusion because some developers may use the share button for an arrow and vice versa, right? So the same icon can have different functionality in different applications. So if you think about it, you need to look at testing the data to see how similar or dissimilar things are in your training set and figure out how to go back in and make sure that the AI can distinguish between things that are very similar. It's not a black box. It's not a magic box. It learns from these things. And if you put confusion into the system, it'll come out the other side. So what we did is we removed a lot of the ones that were causing ambiguity, and it got better. Not perfect, but it got better. Cool. So we're almost on perfect on time, I think, here. So again, I want to say that all of this problem, testing AI systems, if you're intimidated by it, usually I say, oh, AI is easy. It's not a Python call or something like that. It's hard. It's DARPA freaking hard, right? The US government can't figure out what to do about this problem. So if you're interested in the extreme end of testing, that's one thing to go look at. Hopefully they'll just figure it out and we're done. That would be awesome. I doubt it. Another thing I want to note is, I've told this a couple times recently, but when I went from, this is the AI mentality, is when I went to I said during the lightning thing, when I moved from Bing to Google, I was like, I finally got inside the magic castle, and I was, a tester, and like, oh, the developers are always better and smarter or whatever. And I walk over to, there was a lot revealed there, huh? Therapy for years, probably, I should have been. I go to Google, and I go through the building that's the search building. There's like one building that does all the search engineering. And not a single one of them had a development title. They weren't engineers. They weren't software engineers, software design engineers, development engineers. They were literally search quality engineers. So if there's one thing you take away from this whole spiel, is that the creme de la creme of the Google engineers working on AI systems call themselves search quality engineers. That sounds a whole hell of a lot like a tester, doesn't it? Because guess what they're doing every day? The machine does its thing. They're just testing all damn day. So there's a beautiful opportunity here for everyone in testing to realize there's an easy transition. We're actually, if you pay attention, you're going to be the next wave of experts in this engineering world. The AI is replacing normal engineers. It's even replacing AI engineers faster than them. But guess what it's not doing? The testing, right? The testing the things that's left behind. And that's the people. When I go in that building, you go in the parking garage, there's a lot of Ferraris and cars I didn't even know. I didn't recognize, right? They're cool looking, right? But they were really just very sophisticated, glorified testers. So if you think about this, you don't have to go through automation, learn to program, you can try to be an AI engineer. I'd almost suggest you actually just be the best damn tester on the planet, and you'll be the most desired and least, and there'll be the least number of qualified people for that role in the coming future. Data is dangerous in AI. Yeah. So then last, the future, AI is training itself now. Again, AI engineer jobs are going away. You can play with it yourself. And I'll leave you with this. The end game for all this stuff, it looks like, is that, have you ever heard of GANs? They're generated adversarial networks. What it is now is we're starting to realize that you can have, not only can you have one AI train another AI without a human, right? But you can now pit them against each other. They fight each other, and they become superhuman. They become better than you. They can become better than the training data, right? So what's interesting here is this discriminator on the right-hand side is actually ultimately a tester. It's creating examples to test the other neural network. So if you want to know when testing jobs really go away, it's when GANs proliferate, because the AI is actually doing the testing for itself without us in the loop at all. So there you go. There's a Diani style slide. Cool. That's it. I'm Jason Arbon at test.ai. Email me if you want to geek out on this topic. Appreciate your time. Thanks.